What makes Ford's factories so futuristic, and how are robots changing car manufacturing on such a large scale? These are sci-fi movie-style facilities where robots and humans work together to build millions of vehicles in record time and with unheard-of precision. How is it all pulled together? This process begins with raw materials and some of the most sophisticated machinery on the planet. But how does a simple sheet of metal become the body panels of a car? At Ford's futuristic factories, the process begins with raw materials, steel and aluminum designed and formed to become the core components of every vehicle. The seamless integration of advanced robotics, precision engineering, and colossal machinery allows this transformation to take place. At the core of this operation are massive stamping presses. These machines apply immense pressure, up to 3,000 tons, to mold raw steel and aluminum into precise shapes. Components such as hoods, doors, roofs, and fenders are formed with an accuracy that is virtually impossible to achieve manually. Aluminum is prized for its lightweight and corrosion-resistant properties, making it an ideal choice for hoods, roofs, and doors, where reducing weight is critical for fuel efficiency and vehicle performance. Its malleability also allows for intricate designs and smooth finishes, contributing to both aesthetics and aerodynamics. Steel, on the other hand, is valued for its strength, durability, and cost-effectiveness. It is often used in areas requiring robust structural support, such as the frame, chassis, and reinforcement bars. High-strength steel can withstand significant impacts, making it crucial for passenger safety in collisions. The process begins as large coils of raw steel or aluminum are fed into the system. Sheets are cut and prepared for stamping, where they are pressed into molds with millimeter-level precision. The emphasis on millimeter-level precision isn't just a matter of quality control. It directly affects the vehicle's performance, safety, and assembly efficiency. For instance, a precisely stamped door panel ensures a snug fit, improving aerodynamics and reducing wind noise, while also ensuring the integrity of crash protection zones. Similarly, exact tolerances in stamped hood components facilitate proper alignment with engine bay components, crucial for maintenance access and safety mechanisms. By achieving such accuracy, Ford not only upholds strict quality standards, but also minimizes waste in the need for manual corrections, optimizing the entire production process. This ensures that every part meets strict quality standards and also snaps into the place perfectly. The risk of even the slightest deviation from a large-scale operation would have major downstream inefficiencies, but Ford's automated systems eliminate that risk. The use of advanced robotics enhances the efficiency of this operation. Robots are responsible for loading raw material sheets into the presses and unloading the finished parts. The robotic arms operate in split-second timing, carefully handling materials and keeping every step in sync. This approach drastically decreases the margin for error and guarantees consistency and low waste, both of which are extremely important. These tasks can be performed by robots around the clock and at a productivity level that would not be possible with human labor alone. Robots don't just perform repetitive tasks, they are programmed to adapt and self-correct. For instance, AI-driven systems, such as Ford's Mobile Artificial Intelligence Vision System, help identify defects during the manufacturing process. This system, used across multiple global facilities, has inspected millions of parts, enhancing overall quality control and reducing production downtime. The combination of robotics, AI, and advanced logistics allows Ford to maintain a high level of precision in manufacturing while adapting quickly to market demands. The scale of this operation is staggering. In Ford's largest facilities, these robotic systems produce tens of thousands of panels daily, contributing to the assembly of millions of vehicles annually. For context, Ford's factories press enough metal in a year to construct over 2 million vehicles. Each press line can generate up to 10 panels per minute, operating with near zero downtime. This scale would be impossible to achieve without the advanced robotics and machinery that Ford has developed over the decades. Ford has implemented advanced robotics and automation across much of its production line, significantly improving efficiency, quality, and safety. Approximately 70% of Ford's production tasks are automated, a figure that reflects the company's commitment to reducing errors and increasing productivity. Automation has also played a key role in improving workplace safety. The introduction of robots for heavy lifting and precise tasks has contributed to a 70% reduction in injuries among Ford's workers. Once the parts are pressed and precision-shaped, the next challenge awaits, bringing them together to form the car's skeletal structure. How does Ford ensure strength and durability while maintaining lightning-fast speed? The answer is in the robotic welders, thousands of them working to fuse metal parts faster and more accurately than humanly possible. Once the pressed components, like doors, roofs, and side panels, arrive from the pressing area, the welding process starts. Specialized welding tools are added to robotic arms, which take over and perform all kinds of welding with stunning precision. The most common technique is spot welding, which creates small, strong welds at key structural points, ensuring the frame and other parts are put back together securely. A single car frame will need over 5,000 welds to meet the required strength and durability standards, and each spot weld takes place in milliseconds. In areas that demand a smoother and more continuous join, like roof seams, robots employ high-precision laser welding. This technique produces flawless connections while minimizing heat distortion, ensuring that the surrounding material remains intact. For sections exposed to harsh conditions, such as the underbody, seam welding is used to create watertight seals. This method is crucial for maintaining the vehicle's durability and protecting critical components from moisture and debris. Throughout the process, these robotic systems operate with incredible accuracy, ensuring that every weld is placed within tolerances as small as a fraction of a millimeter. While the welding itself is impressive, what sets Ford's process apart is the advanced automation and artificial intelligence that power it. Each welding robot is equipped with sensors and AI-driven systems to monitor quality in real time. Cameras and laser scanners analyze every weld, detecting defects or inconsistencies. If an issue is identified, the system immediately adjusts parameters, such as heat, pressure, or alignment, to correct the problem without halting production. It also reduces waste by preventing flawed parts from advancing down the production line. Over time, AI systems learn from data, continuously refining their performance to optimize speed and precision. With the car's frame complete, the next phase of the process begins. Here, robots and humans work side by side to bring the vehicle to life, adding everything from engines to interiors. How does a bare metal frame transform into a fully functional car in just a few hours? This phase of production is a feat of engineering and coordination, where thousands of individual components are transformed into a cohesive, functioning vehicle. The complexity lies in the synchronization of these systems. Every bolt, panel, and weld must align perfectly. This phase is where cutting-edge robotics meets human expertise, turning countless individual parts into a cohesive whole, the assembly line. Ford's assembly lines are a glimpse into the future of manufacturing, where robotics and human labor come together in perfect harmony. Collaborative robots, known as cobots, perform heavy-duty tasks with unerring precision, such as installing engines, seats, and dashboards. These robots operate side by side with human workers, who focus on delicate adjustments and fine-tuning tasks that require the sharp eye and steady hand of an experienced technician. For example, while a robot secures a dashboard into place with millimeter accuracy, a worker ensures its alignment with surrounding panels, making micro adjustments that enhance both functionality and aesthetics. What sets Ford's assembly lines apart is their incredible customizability. Powered by advanced AI, these lines can adapt in real time to handle different vehicle models and customer-specific trims, all on the same production line. Whether it's switching from a standard interior to a premium leather option or accommodating a unique paint color, the system seamlessly transitions between configurations without slowing production. This level of flexibility not only meets the demand for personalization, but also maximizes efficiency by eliminating the need for separate assembly lines for each model. The speed and scale of these operations are staggering. Every 30 seconds, a completed car rolls off the line, ready to be shipped around the globe. This pace is made possible by the flawless synchronization of robotic precision and human expertise. Robots take care of high-speed, repetitive operations like welding and bolting, while workers conduct inspections and handle finishing touches. Together, they ensure that each vehicle meets Ford's exacting standards for quality and safety, no matter how complex or unique the build. With the assembly process complete, the cars are almost ready to hit the road. But first, they need the perfect finish. How do robots make sure every car departs with a perfect, flawless exterior? And what ensures that every Ford car withstands the test of time? The answer lies in Ford's highly advanced paint shops, where robotic precision meets eco-conscious innovation. Beyond aesthetics, this stage of production is about building a durable exterior that protects the vehicle and a signature finish that defines the brand. This process begins with an automated pre-treatment phase where the car's body is thoroughly cleaned and treated to remove contaminants and prepare the surface for paint adhesion. The vehicle is then coated with a special primer that serves as a protective barrier, preventing rust and corrosion from forming over time. This primer is applied with robotic arms equipped with high-precision spray guns, ensuring uniform coverage that bonds seamlessly with the metal surface. Once the primer has dried, the base coat is applied. This is where Ford's commitment to color accuracy and consistency is most evident. Robots, working in perfect synchronization, apply the base coat in a carefully controlled manner, adjusting spray patterns and pressure to guarantee even distribution across every curve and edge of the vehicle. Ford's advanced robotics allow for quick changes between colors or finishes, responding to customer preferences and orders without disrupting the production flow. Whether it's a solid color, metallic finish, or specialty hue, the precision robots ensure that every vehicle matches the exact specifications down to the smallest detail. The final layer, the clear coat, provides both visual appeal and functional protection. This glossy finish is not only aesthetically pleasing, but also plays a crucial role in protecting the vehicle from environmental damage. The clear coat shields the base paint from harmful UV rays, preventing fading and discoloration over time. It also serves as a barrier against scratches, dirt, and chemicals, keeping the car's exterior looking pristine for longer. Ford's paint process is highly automated, yet it incorporates constant quality checks. Sensors integrated into the robotic arms continuously monitor the paint thickness, texture, and coverage. If any inconsistency is detected, the system automatically adjusts the robot's motion or alerts operators to make corrections. This constant feedback loop ensures that every vehicle receives a uniform finish, even with the high volume of production at Ford's largest facilities. Ford's commitment to sustainability is on full display in the paint shop. Traditional painting processes are resource-intensive, but Ford has implemented cutting-edge technologies to minimize environmental impact. First, the paint used is formulated with low-emission, water-based solvents, significantly reducing the release of volatile organic compounds into the atmosphere. Additionally, advanced recycling systems capture and reuse excess paint, reducing waste by up to 30%. Air filtration systems ensure that any particles released during the process are captured and neutralized, further lowering emissions. Ultimately, the paint process at Ford is not just about creating an attractive exterior, but about building a long-lasting, durable finish that withstands the rigors of time, weather, and wear. It's a perfect blend of innovation, precision, and sustainability that delivers both quality and eco-conscious results. At Ford's largest facilities, the paint shop processes thousands of vehicles daily. Despite this massive output, the quality of each vehicle's finish is meticulously controlled. Robotic systems continuously monitor paint applications, using sensors to detect and correct even the smallest inconsistencies. With the exterior perfected, it's time for one of the most critical steps in the manufacturing process. How do Ford's factories integrate engines, transmissions, and other key systems into the assembled frame? The marriage is an intricate, highly coordinated process. It's the critical stage when the body of the car joins the chassis and powertrain, the foundation of each vehicle's performance and functionality. This is a pinnacle of automation in modern manufacturing, combining robotic precision, advanced logistics, and large-scale efficiency. At Ford's advanced assembly line, the integration of key components is a finely choreographed process where robotic precision and logistical expertise converge to build a vehicle in record time. After the freshly painted and polished vehicle body is carefully moved down the line, robotic arms spring into action, connecting the wheels and suspension systems to the chassis. This stage is critical as it stabilizes the vehicle and prepares it for the next set of tasks. The robots work seamlessly, using high-torque tools to secure the body to the chassis with incredible speed and precision. The forces involved in this step are immense, but the robotic arms handle the pressure effortlessly, ensuring that every part fits perfectly. What is remarkable is how this process, involving parts that often weigh over a ton, takes mere minutes to complete, a testament to Ford's highly efficient manufacturing systems. However, the true brilliance of this phase lies not just in the robots, but in the precise coordination of the entire assembly process. Ford employs a strategy known as just-in-time logistics to manage the flow of parts, ensuring that every component, whether it's an engine, axle, or transmission, arrives at the assembly line exactly when it's needed. This minimizes the need for on-site storage and prevents production delays. It also reduces waste, allowing Ford to maintain a lean operation while keeping the production line moving smoothly. The flow of parts is managed by AI-driven supply chain systems, which track and coordinate the delivery of components with pinpoint accuracy. These systems ensure that the right parts, whether for a hybrid, electric, or gasoline-powered vehicle, arrive at the right moment in the assembly process. If the line needs a specific powertrain for an electric vehicle, for example, the system ensures that it's in place just as the body and chassis meet on the line. This level of precision is what enables Ford to produce a variety of models and trims on a single assembly line without disrupting the flow of production. The ability to seamlessly transition between different configurations while maintaining uninterrupted efficiency is key to Ford's success in meeting market demands for diverse vehicle types, all while adhering to strict timelines. The integration of AI, robotics, and logistics management ensures that every vehicle, no matter its specifications, is built with the same level of quality and efficiency. Now that the car is fully assembled, it must undergo rigorous testing to ensure it meets Ford's exacting standards. From structural integrity to performance metrics, every detail is scrutinized before the vehicle leaves the factory. Combining robotic precision, AI analysis, and rigorous dynamic testing, Ford's system leaves no detail unchecked. This final and essential step in the manufacturing process guarantees that each vehicle is fully prepared to excel on the road. The first stage of quality control relies on a network of robots equipped with high-resolution cameras, laser sensors, and other advanced imaging technologies. These systems inspect every inch of the vehicle, from the alignment of body panels to the smoothness of the paint finish. Using artificial intelligence, these robotic systems can detect microscopic imperfections that are invisible to the human eye, such as hairline cracks, uneven coatings, or alignment deviations. By analyzing data in real time, AI adjusts manufacturing parameters to prevent recurring issues, ensuring continuous improvement throughout the production process. For example, robotic arms equipped with tactile sensors can measure the torque on bolts and fasteners to confirm they meet specifications, while automated scanning systems verify that critical welds are structurally sound. After passing robotic inspections, vehicles undergo dynamic testing to evaluate their real-world performance. In specially designed testing facilities, cars are subjected to rigorous simulations that mimic the conditions they will face on the road. Each vehicle is tested for key performance metrics, including handling, braking, acceleration, and suspension. For instance, robotic systems control vehicles as they navigate simulated tracks, making precise measurements of how they respond to turns, inclines, and sudden stops. This ensures that steering systems, braking components, and powertrains function under a variety of conditions. In addition to performance testing, vehicles are evaluated for noise, vibration, and harshness. Acoustic sensors measure cabin noise levels at various speeds, while vibration tests ensure a smooth driving experience. For electric and hybrid models, special attention is given to battery systems and energy efficiency, ensuring they meet Ford's benchmarks for safety and performance. Once a vehicle passes all quality checks, it is prepared for shipping. Robots play a key role in this stage as well, efficiently loading vehicles onto transport carriers destined for dealerships around the world. Ford's just-in-time logistics system ensures that vehicles are shipped in the correct sequence, allowing dealerships to receive specific models and trims tailored to regional demand. This streamlined approach minimizes delays and ensures that customers receive their vehicles as quickly as possible. Every day, thousands of cars leave Ford's factories, heading to markets in over 100 countries. This global scale of operation is made possible by the integration of robotics, AI, and meticulous quality control processes, which guarantee that each vehicle upholds Ford's reputation for excellence. Could you imagine that Ford leaves so much of the work up to robots? That trust must be solid. If you enjoyed this video, make sure to give it a like, subscribe, and share our channel for more videos like this.